Welcome to Rock Cycle with Miss Ungerleider, Unit 7, Lesson 2, Cornell Notes. Please put your first and last name on your Cornell Notes sheet, along with today's date and the topic. Our topic today is the rock cycle. Okay, let's get started. So the rock cycle is the continual process by which new rock is formed from old rock material. Please put the word rock cycle in your left-hand column, or you could even turn it into a question. What is the rock cycle? I want you to think back to some of our earlier units where you learned about the law of conservation of matter and the law of conservation of energy. All of the rock that exists on the earth is here. It's not going anywhere. It cannot be created. It cannot be destroyed. It can only be transformed into different types of rock. And it has done that through a process called the rock cycle. And what you need to understand about the rock cycle is that it takes millions of years for some of these things to happen. You do not have to draw the diagram, but when you're finished writing, take a look at it. Okay, the first type of rock that we are going to talk about in the rock cycle is called an igneous rock. And an igneous rock is a volcanic rock. I even like to draw my eye in igneous to look like a volcano. That helps me remember that an igneous rock is a volcanic rock. An igneous rock is formed when magma cools. And that can take place inside the earth or above the ground. So when an igneous rock is formed inside the earth, we call it intrusive. We call it an intrusive igneous rock. This might happen in a magma chamber. And if that igneous rock is heated and undergoes a tremendous amount of pressure, it could become a metamorphic rock. Or it could be melted again to form new magma. Now, when an igneous rock is located above the ground, that's what we call an extrusive igneous rock. And just like all the other rocks that are located above ground, they are subject to weathering and erosion, where they can become what's called a sedimentary rock. And you'll notice that being a pattern throughout the rock cycle. That rocks that are on Earth's surface are constantly being weathered and eroded and turned into sedimentary rock. How many of you guys have seen pictures of, or maybe even visited, the black sandy beaches of Hawaii? Okay, I want you to think about why Hawaii would have black sandy beaches. Yes, it does definitely have something to do with the lava fields, the igneous rock, the constant lava flow that creates black rock above the surface, and then it's weathered and eroded, and eventually it turns the beaches sand black. Okay, So take a look at this slide. Here you have a diagram of an extrusive igneous rock formation. You may want to draw this on your Cornell notes. Here you have an intrusive igneous rock formation inside the magma plume. These are 3 different examples of types of igneous rock. You've got obsidian that looks like black glass, pumice, which shoots out of the top of an exploding volcano. It's very light, it's airy, it cools super fast, and because it cools fast, it has these air pockets inside of it. And the pumice is actually, you can use a pumice stone to scrape dead skin cells off your feet or hands. Another type of igneous rock is granite. And then over here, you see the active lava fields in Hawaii. Those are all your igneous rocks, your volcanic rocks. Okay, the next type of rock we're going to talk about that exists within the rock cycle is our sedimentary rock. Sedimentary rock is formed when sediments compact and cement into layers. And fossils are only found in sedimentary rocks. So if I gave you a rock quiz, and I sat a rock out on the table and I said, what type of rock is this? And you noticed there was a fossil inside of it, you would automatically know that it is a sedimentary rock. Okay, sedimentary rocks, when they are inside the earth, okay, remember over time, they are just pushed further and further and further and deeper underground. So when a sedimentary rock is deep within the earth and exposed to a tremendous amount of heat and pressure, it can form a metamorphic rock. Or, most commonly what happens to sedimentary rocks is they're located above the ground and they're weathered again and again to form new sediment. Now, sediment is those little bitty tiny pieces of broken off rock. And sediment can be cemented and compacted into forming a sedimentary rock, which you'll see an example of in our next slide. Can I move forward? Okay, so here you have a picture of the sedimentary rock outcrop. Raise your hand if you've seen one of these before in real life. Okay, think about where you have seen them. Okay, and we will discuss that. Okay, but notice the layers. Typically, the layers at the bottom will be less defined. They'll be thinner than the layers at the top. Think about why that might be. Okay, here's some pictures of sedimentary rock. Over here you can see the fossils. You've got sandstone, which is formed from cementation. And then, of course, this white rock over here, which is called limestone. The interesting thing about limestone is that it's formed underwater. So you will commonly find it in places where there was at one time an ancient ocean. There's a lot of limestone in Texas because Texas used to be underwater. And that's why a lot of the buildings there are made of white rock or white stone. Okay, so metamorphic rock is the third type of rock that we're going to discuss in the rock cycle. And remember, metamorphic means to change. And that's exactly what happens to a metamorphic rock. Metamorphic rock is pushed further and further and further into underground. And once it undergoes a tremendous amount of heat and pressure, it can change into what's called a metamorphic rock. And depending what elements are present, or whether there is water present during the rock formation, that'll determine what type of rock is created. Sometimes they're pushed so far into earth and heated at such an extreme temperature that they may melt to form magma. And then also, to go along with our theme of sedimentary rock, when metamorphic rocks are above ground, they may weather and erode to form sediments. Okay, here are 3 examples of metamorphic rock. You may want to go ahead and write your examples. Quartzite, marble, slate. Marble is beautiful. It is expensive. It's a bad idea to put it on your countertop. Okay, it's not very durable. It stains. It has to be sealed all the time. If you're really wealthy and you don't use your kitchen a lot, sure, go ahead, put it on your countertops. Okay? But typically, it's not a good idea. Slate is another type of metamorphic rock. You do not have to write all of this, but let's write some key terms. And I want you to take a look at this. So, foliated versus non-foliated are 2 words that describe types of metamorphic rock. And if you'll look real quick before you read, I want you to look at the gneiss on the left and the quartzite on the right and identify the differences between the 2. Okay? The one on the left, gneiss, is what is described as being a foliated metamorphic rock. Do you see those bands? The lines? Okay, those are called bands. They're formed under a great amount of pressure. So the minerals are actually aligned into bands. So that gneiss, that picture of that gneiss rock on the left, would be considered a foliated metamorphic rock. Okay? Now the opposite would be a non-foliated metamorphic rock. And those are rocks that form under a lower amount of heat and pressure, and the minerals do not align into bands. So you might want to draw that on your Cornell notes. Okay, where your foliated rocks, they form bands because of a high amount of pressure. And then the non-foliated rock is formed under a lower amount of heat and pressure, so it does not form those bands. And those are words that are just used to describe metamorphic rocks. Foliated versus non-foliated. Okay, the next slide is going to be on your test, so you might want to star it, circle it, just make sure you notate that it is important. Okay, so we've all seen these beautiful slabs of granite. And typically, people want them because they have these beautiful crystal formations. What you need to understand about crystals is that the large rock crystals are formed when rocks cool very slowly inside the earth. So essentially, the larger the crystals, the slower it cools. So a rock that has no crystals or very small crystals would have cooled more quickly. And then we all know about rocks that cool very fast, like pumice, okay, that would cool so rapidly that it traps air bubbles inside of it. Okay, let's go ahead and talk about the law of superposition. Today we are going to discuss how this law relates to geology and rocks. But as we're discussing the law of superposition, I want you to think about where it is used in other areas also. Okay, so the law of superposition, as related to geology, states that when rocks are deposited in layers, the youngest layer is on top and the oldest layer is on bottom. Okay, so that can, in geology, that can relate to rocks, that can relate to soil. Down here, as it relates to soil, you can see the younger soil is at the top, the older soil is at the bottom. Over here in this cross section of rock, there are fossils. Fossil A would be a younger fossil than fossil D. Fossil A would be the youngest fossil. Fossil D would be the oldest fossil. I want you to think about other areas of science where we could use the law of superposition, and we'll discuss that. Okay, let's go ahead and write down some information about James Hutton. I'm okay with you just jotting down key terms. So make sure you put his name to the left. You could say, who is James Hutton? He was a Scottish geologist. He lived from 1726 to 1797. And he was first one to use the law of superposition to find the relative age of rock layers. He's also known as the founder of modern geology. That's Mr. James Hutton. Okay, I'm not going to require you to write anything down for the next 3 slides, but I do want to show them to you. Here are some vocabulary words that are really important. You can find these on your vocabulary list, so make sure you know them for the test. Cementation, compaction, sedimentation, weathering, erosion, and deposition. Thank you so much for taking Cornell Notes with me today.